Hi folks, this is 8F on page 106. So here this is a pretty common example of where we have to use more than one rule. So very often you're not just using the quotient rule or the chain rule or the product rule. You often have to combine at least a couple of them. So I'm just going to take a look at one way to solve this that I'm actually not going to use, because one option you do have is to distribute this exponent for the numerator and denominator. So that just becomes the derivative of x squared minus 3 to the fourth over x squared plus 3 to the fourth. And you can use the quotient rule. And then, of course, in the process of finding the numerator's derivative and the denominator's derivative, you'll have to use the chain rule. Okay, so certainly that's an option, but I think there's a better way, and the better way I would say is to use the chain rule first. Okay, and usually that's a good start. So what I'm seeing here is a composite function, and that composite function is, x to the 4, okay, and then the interior function x squared minus 3 over x squared plus 3. Okay, and I think of this all as one function because I know I can use the quotient rule on that. Okay, so if you let this be your u, if you think of that as your u. So first you have to take the derivative of u to the 4, which of course is just 4u cubed. Now you're noticing here that I'm going to write a lot less than I did when I was first solving these. So 4u cubed, and of course u is just equal to this thing here. So x squared minus 3 over x squared plus 3. Okay. So that's my first derivative, and then I have to take the derivative of u with respect to x. But to take this derivative, I have to use the chain rule. The quotient rule. Okay, so let me do that. So derivative of the numerator, 2x times the denominator function, x squared plus 3, okay, minus the numerator function, x squared minus 3, times the derivative of the denominator, 2x. Okay, and all over the denominator squared. Okay, and now I'm going to start simplifying these things, because eventually once we start using derivatives and applications, we will have to simplify them. Okay, so first thing I notice is that I have an x squared plus 3 cubed in this denominator, and then here I have an x squared plus 3 squared. So I'm going to bring those together. So what I'm going to do is I'm going to distribute my exponent 3, so I've got x squared minus 3 cubed. And then in the denominator, I've got this thing cubed times this thing squared. So add the exponents, gives me x squared plus 3 to the fifth. Okay, and now let's simplify this this other thing in brackets. Okay, so here we've got 2x cubed plus 6x, and then here I've got minus 2x cubed. Okay, and be careful here, plus 6x again because of the double negative. Okay, and here nice stuff happens. The 2x cubes cancel out, and I'm just left with 12x in this bracket. So now I'm going to bring everything together. So 4 times 12x is 48x times x squared minus 3 cubed all over x squared plus 3 to the fifth. Okay, and that's about as simple as I can get it. Okay, so just to recap here, when I see something like this that's got some big expression to an exponent, chances are, or best way to do it is to use the chain rule. So first I apply the chain rule by thinking of this as my interior function, my u. So first I take the derivative of u to the fourth with respect to u. That's this one here. And then to find the derivative of the inside function, I just had to use a quotient rule and then simplify. Okay, that's it.